Hello friends, in this video we will be solving Get Numericals on Fourier Series. Let us begin. The first question is from Get 2016. It says, which one of the following is an eigenfunction of the class of all continuous time linear and time invariant systems? That is, they are talking about LTI system, where u of t denotes unit step function. So this u of t, they refer to option A. So they are telling you in option A, the u of t present, it is unit step function. So let us ignore this comment and we'll again concentrate on the question. What it says, which one of the following is an eigenfunction for class of all continuous time LTI system? In mathematics, you must have learned the eigenvector and eigenvalue. So what is eigenvector and eigenvalue? For example, you have, suppose you have some vector x, and after transformation you have output as lambda x. So this is what we called as vector. After transformation, again you got same vector at output multiplied by some scalar value. So this lambda is some scalar value. So for x vector, again in the output you are getting same x vector multiplied by at the most some non-zero scalar value. In that case, this vector x is called as this vector is called as eigenvector. And the quantity or magnitude or a scalar value by which this vector got multiplied is called as eigenvalue. So this lambda is called as eigenvalue. So for transformation, you're using, let's say, matrix X. So A is a processing matrix or a transformation matrix. So whenever for different values of vector like x1, x2, x3, you may not get same values of a vector. You may not get same values of vector at output. But for a particular value of vector, you get same vector value at output. At the most, it is multiplied with some non-zero scalar value. In that case, that particular vector is called as eigenvector, and scalar value by which it got multiplied, that scalar value is called as eigenvalue. Or graphically, or to be very specific, geometrically, if I want to explain, let's say we have x1 vector like this. Let's say x2 vector is like this and x3 vector is like this. So after processing at output, suppose you are getting output for x1 vector like this, output for x2 vector like this, and output for x3 vector like this. So let me call this output as y1, y2 and y3. So these are y1 vector, y2 vector and y3 vector. So if you compare for x1, the direction in which x1 is pointing to, in the similar direction y1 is pointing, maybe we can have some higher magnitude. But this is not the case for x2 and x3. The direction which is pointed by x2, in the same direction it is not pointed by y2, and therefore I will declare that x2 cannot be the eigenvector. Similarly, x3 cannot be the eigenvector. But since for x1 the direction is written by y1, and therefore I will declare x1 is the eigenvector, and the quantity by which this y1 is stretched by, that scalar value, is known as eigenvalue. So I'm sure from mathematical point of view we have understood what is meant by eigenvector and eigenfunction. But then let's come back to our signals and system concept or signals and system subject, and let us understand what is the significance of eigenvalue, eigenvector, or in this case we call that as eigenfunction. So let us understand what is meant by eigenfunction. For a particular system, and to be very specific, it is LTI system. Let's say for input x of t, I'm getting some output y of t. And if I come to know that y of t is equal to k times x of t. So as you can see, for this input, output is k times x of t. So can you see that y of t is simply equal to x of t only, which is just multiple of k, where k is just a constant value. It means for this particular input x of t, I'm getting in output same x of t as it is. Only thing is it is multiplied with some constant value. It means my input characteristics are retained even at output also. Even at output, even though it is traveling through some system. In that case, for a particular input for which you get same characteristic at output, that particular input is called as eigen function. Why it is called as a function? Because x is function of time. So a particular eigen function. So for a particular input, I get output in this form, that is k times x of t. So x of t retains their characteristic at input as well as output. Then that x of t is called as eigen function, and k by which it got multiplied is called as eigenvalue. Is that right? So let us go back to the question and read the question carefully. They are asking you what is the appropriate eigenfunction. So do you understand that these four options are different values of x of t, which proves to be the eigenfunction for all types of LTI system? Then let me tell you, option C is the correct option, because if you read the literature of LTI system, there they always say that e to the power j omega naught t is the most popular eigenfunction for that LTI system. But then how option C comes out to be the eigenfunction, let us prove it. So we are checking for option C. So x of t is e to the power j omega naught t. Now, a particular LTI system, if x of t is known to me, and if I want to determine what is y of t, at least impulse response h of t must be known to me. In that case, you know that what is the relation between x of t, h of t, and y of t? It is simply y of t equal to x of t convolved with h of t. Is that right? But I can rewrite x of t convolved with h of t as h of t convolved with x of t. It is one and the same thing. So this is your y of t. And you know that in continuous time, we can use the integral formula, that is integrating over minus infinity to infinity h of tau x of t minus tau d tau. Then further I can write y of t as minus infinity to infinity. H of tau is not known to me, so let me keep this as h of tau only. What I know is x of t. From x of t, if I want x of t minus tau, the trick is just to replace t with t minus tau. So let me rewrite that e to the power j omega naught, in bracket we will have t minus tau d tau. Now since we are integrating with respect to tau, t is a constant. So I can rewrite y of t as minus infinity to infinity. I'll take e to the power minus j omega naught t out. So what remains inside is h of tau e to the power minus j omega naught tau d tau. So let me rewrite that y of t. So y of t is e to the power minus j omega t. We have integration from minus infinity to infinity h of tau e to the power minus j omega naught tau d tau. So let me tell you, this whole thing is nothing but a Fourier transform formula. After solving this, you get h of omega. So you get h of omega. So y of t is equal to e to the power minus j omega t multiplied with h of omega. Why this integral I'm equating to h of omega? You will understand it better when we will start with Fourier transform. Or simply, let me tell you, f of t is a function. If you take a Fourier transform of it, it becomes f of omega, where f of omega is given as integrating over minus infinity to infinity f of t e to the power minus j omega t dt. So you can refer this formula and you can understand that why I have replaced it as h of omega. So please try to understand y of t when I say it is equal to e to the power minus j omega t h of omega. This is function of omega. When I say it is function of omega, it means it is not function of time. And since I'm talking about y of t, that is in terms of time domain, this becomes constant for me. So how come it is constant? Once again, it is h of omega. When I say h of omega, it is function of omega and it is independent of time. So for me, from time point of view, it is constant. So I would say y of t e to the power minus j omega t is x of t itself. So I know that when y of t is simply constant k times x of t for input x of t, then x of t becomes what? Eigen function. Therefore, I can say that e to the power minus j omega t is the eigen function. Therefore, e to the power minus j omega t or e to the power j omega t is the eigen function. So option C is the correct option. When we took this out, it was positive only. So this is positive. This is also positive, right? So e to the power j omega t is one of the x of t which can be treated as the eigen function. If you try rest of the options, you will not get in this format. So let's go to the next question. A continuous time input signal x of t is an eigen function of an LTI system if the output is. And I would request that you read options by your own and try to get the correct option out of it. So with our discussion, we have already seen that whenever y of t is simply k times x of t, only then x of t is called as eigenfunction, k is called as eigenvector, k is called as eigenvalue. Is that right? So definitely it is option A. So whenever output y of t is k times x of t, where k is eigenvalue, only in that case I would say that x of t is an eigenfunction. Let's go to the next question. Let f of x be real periodic function satisfying f of minus x equal to minus of f of x. The general form of its Fourier series representation would be. So what do you come to know from this given relation? So we know that when f of minus x is equal to minus of f of x, it means we understand that f of x is odd signal. And whenever it is odd signal, we know that a naught is always 0. In fact, ak is also 0. Only bk will have some non-zero value and it will contain only sign terms. Is that right? So let us see. Option A and option C can be eliminated because it has some a naught value. And we know that a naught value is 0 if it is odd function. So within option A and option D, we have to select the correct option. The other clue is that it will have only sign terms. But if you again compare option B and option D, both of them are having only sign terms. Am I right? So both of them are having only sign terms. But now the difference is in option D, suppose if you substitute the value of k equal to 1. So after substituting value of k equal to 1, so in fact we should start with k equal to 0. So if I substitute k equal to 0, it will become a1 sine of x. Then for k equal to 1, it will become, it is 2k plus 1, right? So it will become a3 sine of, since k value equal to 1, it is 2 plus 1, which is 3, which is 3x. Then for k equal to 2, it will give you a5 sine of 5x. So what does that mean? Option D says that it has got only odd harmonics, because what we have is omega naught, here we have 3 omega naught, here we have 5 omega naught. What does that mean? It gives you only odd harmonics. So tell me, for a particular signal f of x in Fourier series, we get only odd harmonics provided the given f of x is having half wave symmetry. Am I right? Only if the given f of x is satisfying half wave symmetry. Here they have given us information that f of x is odd signal, but they haven't informed us, or they have given no clue that the given f of x is having a half wave symmetry. If it is so, we cannot say, or we cannot be so sure that it will be having half wave symmetry. So we shouldn't guess it this way. So definitely option D is not the correct option. The most appropriate option is option B, which is having all harmonics, that is from k equal to 1 to infinity. So option B doesn't tell you that even harmonics are present or only odd harmonics are present. Option B says all harmonics are present. Option D says only odd harmonics are present. And since more information about f of x is not given to us, we cannot claim that f of x is a half wave symmetry signal. So option D would be inappropriate answer. Let's move to the next question. The Fourier series for a periodic signal is given as x of t is equal to cos of 1.25 t plus cos of 2 pi t plus cos of 2.8 pi t. The fundamental frequency of the signal is. So you have to only find a fundamental frequency out of it. And we have already solved this kind of problems. So now we will see. From the first signal, omega 1 is 1.2 pi, omega 2 is 2 pi, and finally we have omega 3 as 2.8 pi. I can rewrite omega 1 as 12 upon 10 pi. I'll keep omega 2 same, that is 2 pi, and again omega 3 can be written as 28 by 10 pi. In that case, by writing shortest form of omega 1, I can rewrite this as 6 pi by 5, omega 2 same as 2 pi, and finally omega 3 in its shortest form I can write 14 pi by 5. So from multiple values of omega, if you want to get omega net or a fundamental frequency, we have already learned this way. Omega net, that is fundamental frequency, is GCD of numerator, that is 6 pi, 2 pi, 14 pi, divided by LCM of denominators. So here denominator is 5, denominator is 1, and we have denominator as 5. So greatest common divisor from the numerator, it is clear, it is 2 pi, divided by LCM is 5. So this is in terms of radians per second. So 2 pi by 5 is a fundamental frequency, but angular frequency having unit as radians per second. Here we want output in terms of hertz. So definitely I would say frequency net, that is fundamental frequency, is omega net divided by 2 pi. So if you do so, then 2 pi gets cancelled. So f net comes out to be 1 by 5 hertz, and 1 by 5 hertz is nothing but 0.2 hertz. So option A is the correct option, right? Let's move to the next question. A signal x of t is given by, so they have given some constraints on x of t. As you can see, the value of x of t is 1 within the interval from minus t by 4 to 3t by 4. X of t is minus 1 within the interval from 3t by 4 to 7t by 4. And also x of t is minus of x of t plus t. So they have given some information about x of t. And what they ask, which among following gives a fundamental Fourier term for x of t? When they say a fundamental Fourier term, it means they are talking about omega naught frequency. Let's say if they are talking about a third harmonics, then they talk about 3 times omega naught t term. Am I right? So what I'll do is, from the given description of x of t, I'll try to get a graphical information for x of t, from which we'll get a fundamental time period, and from fundamental time period we will get fundamental frequency, and then we'll get back to the question. So let me just copy this. X of t is equal to 1 within the interval from minus t by 4 to 3t by 4. So x of t is equal to 1 from minus t by 4 to 3t by 4, and x of t is equal to minus 1 from 3t by 4 to 7t by 4. So I have already marked those intervals over here. So let us see the first interval from minus t by 4 to 3t by 4. We have amplitude as plus 1. So let me draw plus 1 here. And from 3t by 4 to 7t by 4, we have amplitude equal to minus 1. So we got negative value from 3t by 4 to 7t by 4. And since the question is related to Fourier series, definitely the given signal must be a periodic signal. So this thing will keep on repeating. So this is simply a square wave, right? So this will keep on varying. From 7t by 4, again this will become positive. So we have amplitude from plus 1 to minus 1. So this is a simple square wave, am I right? So our plan is to get a fundamental time period. So for one cycle, I can concentrate on this area or this interval. So how do we get a fundamental time period? Simply higher limit minus lower limit, which is 7t by 4 minus minus of t by 4. So it comes out to be 2t. So please understand, a fundamental time period, as usual, it is not t, it is twice of t. So just perform this simple mathematics. You will get fundamental time period as 2t. So when I say a fundamental time period is 2t, I can get fundamental frequency also. So we know that omega naught is nothing but 2 pi by a fundamental time period. So fundamental time period, please don't make mistake to substitute capital T only. It is twice of t. So I'll substitute twice of t. Here 2 gets cancelled. So omega naught is simply pi by t. So this is nothing but a fundamental frequency. Am I right? So let's get back to options and we will see in Fourier series, do we have the same frequency, that is pi by t? So in fact, whether it is cos or sine, it is in terms of cos omega naught t, or if it is sine, it is sine in terms of omega t or omega naught t. So what is omega naught? Omega naught is pi by t. So it should look like this, cos of pi by t times t, or if it is sine, it should look like sine of pi by capital T small t. So now option B and option D can be eliminated, because if you see, your fundamental frequency is not matching with ours. So option B and option C can be eliminated. But if you observe option A and option C, the fundamental frequency in both the cases, it is pi by t. Am I right? So we have to differentiate whether it will have cos term or sine term, because rest of the frequency, phase and the amplitude value is throughout same. Am I right? So amplitude value is definitely 4 by pi. We don't have to really calculate it. only we have to identify whether it will have cos term or sine term. So if you remember, whether it will have a cos term or sine term, it depends upon whether the given signal is even or odd. For even signal, we get only cos terms at output, and for odd signal, we get only sine terms at output. Let us verify what is about our signal. So by observation, you can see that it is neither even nor odd. Am I right? It is neither even nor odd, because for signal to be even, the kind of portion that we have on right hand side, we have comparatively little portion on left hand side. So definitely it is not even signal, and secondly, there is no scope that it is a odd signal. So what needs to be done? Whether it will have sine or whether it will have cos term. How do we decide this? So the first point is that it is neither even nor odd signal. If you remember, they have given us one more information about x of t. Your x of t is minus of x of t plus t. So let us see, x of t is equal to minus of x of t plus t. I hope you remember a similar property, that is half wave symmetry property. According to half wave symmetry property, x of t should be equal to minus of x of t plus t by 2. Am I right? So when I'm talking about this property, what we have over here is always a half time period. I repeat, what we always have over here is a half time period. So this is your half of time period. But if you see over here, we don't have t by 2. What we have is t. But you should not forget, for this given problem, we have 2t as a time interval, or 2t as a fundamental time period. So half of it is nothing but t only. Am I right? Therefore, this equation tells you that the given signal is satisfying half wave symmetry property. So this is just satisfying half wave symmetry property. And from half wave symmetry property, we understand that the DC value will be equal to 0, and secondly, only odd harmonics are present. But then when you compare option A and option C, we have nowhere to compare even harmonics or odd harmonics, because both the terms because both the terms are fundamental terms. So these are only fundamental terms, right? So I'm only talking about option A and option C. So curly bracket refers to only comparison of option A and option C. So even though they have given us this third information, it is useless for us. So this is useless for us. At least we have only interpreted that it is having a half wave symmetry. So let us discuss more how we can still compare that we will have only cos component or sine component. So you know that when it comes to neither even nor odd signal, I said in the previous lecture that if it is even signal, then you can claim that it will have only cos terms. For odd signal, you can claim 100% that you will have only sine terms in Fourier series. But when it comes to neither even nor odd signal, you may have both, that is sine as well as cos. You may have only cos, or you may have only sine. That depends upon the given signal. Am I right? Now the question is, if I want to get only sine term or cos term, the only thing is that I have to convert the signal into even signal or odd signal just by using a time shifting property. I repeat, we have to use a time shifting property. So let me tell you, this is x of t. So a signal could be an even signal if it was like this. Am I right? But right now we have a lesser content this side and more content on right hand side. Am I right? So if I want to, let's say, convert it into even signal, I have to advance the signal because I have to shift the signal little bit to the left. So let us determine by how much quantity we need to shift it to the left, so that on both the sides we get common area. Am I right? Because this is what because this is what is required to make the signal as even. So if you can see and if you can observe, if you move to the left by t by 4 quantity, then the signal will become even. It will be minus t by 2 to t by 2 in that case. So if you make your signal x of t to get advanced as x of t plus t by 4, that is advancing the signal by t by 4, then only it will become an even signal. Am I right? So whenever you are going to advance by t by 4, you subtract t by 4 from each time stamp. That is going to do this way, minus t by 4, and from here minus t by 4. And outcome of this 3t by 4 minus t by 4 becomes t by 2, and answer for this is minus t by 2. So what we will have over here is minus t by 2. What we will have over here is t by 2, and definitely this is t and this is minus t. Am I right? So t will not come this way, t will be exactly in the middle way. Okay, that is not our point of discussion. What we have done is we have converted our signal from x of t to x of t plus t by 4, and only then we will have cos component. In this case, suppose we are looking after its Fourier series term, and we don't have to write a complete Fourier series, we have to write only that content which will have a fundamental frequency, that is a fundamental frequency component. Am I right? So definitely it will have cos component. So I'm not interested in magnitude, let me write it as a omega naught t. Am I right? Or let me write this as a cos of. So what was omega naught? Omega naught was pi by t. Is that right? So this is a fundamental frequency component for x of t plus t by 4. Is that right? But you don't want Fourier series component for x of t plus t by 4. What you want it for x of t. Am I right? So the question is, if I have x of t plus t by 4, and if I want x of t, listen to me very carefully what I'm trying to convey you. If you have x of t plus t by 4, and if you want x of t, then what you are supposed to do, just replace t with t minus t by 4. Very simple. I repeat, if you want to convert this x of t plus t by 4 back to x of t, you have to replace t with t minus t by 4. Therefore, see what I'm trying to tell you, x of t plus t by 4 is something that you already have. If you are replacing t with t minus t by 4, then this t by 4 get cancelled and you will get x of t. So this is the basic idea, to replace t with t minus capital T by 4. Is that right? In that case, this is a fundamental frequency component for x of t plus t by 4. I want frequency fundamental component for x of t, then I'm going to replace t with t minus 4. So it will be a cos of pi by capital T as it is, and t I'm going to replace with t minus t by 4. Is that right? So I'll rewrite this as a cos of pi by t minus t by 4. So it is a cos of. Now let me take pi by t inside. So it becomes pi by t minus pi by t by 4. So here t gets cancelled. Finally, you have a cos of pi by capital T minus pi by 4. So this is the fundamental frequency component we have. So if you see carefully, it is nothing but option A. Am I right? So let me tell you, for this neither even nor odd signal, shifting by t by 4, that is advancing by t by 4, you get even signal. If you do exactly reverse, if you delay this signal in such a way that let's say it has become odd signal, so this is the homework I'm now giving you. For this signal, you try to get a fundamental frequency component in Fourier series and then replace t with t plus capital T by 4 instead of t minus t by 4 and try to get the answer. You will not get the same. I hope my idea is clear to you. So in this case, this is the correct option. Now talking about value of a, if you remember, for every square wave we have value as 4a upon n pi. I told you to remember this as coefficient. You know what? Value of a is lying between plus and minus 1. Am I right? So value of a can be taken as 1. Secondly, since they are talking about a fundamental frequency component, it means value of n has to be what? 1. It means it would be simply 4 upon pi. And that's the reason why in every option you will see that amplitude of whether it is sine or cos, it is 4 by pi. So as you can see, it is 4 by pi everywhere. So on the basis of 4 by pi, you could not eliminate any option. So I didn't discuss about it. But just to have some extra discussion, we are talking about this. Thank you.